this is going to be a part 2 of our chapter 6 lecture videos. And the first thing that we're going to talk about today is constructors. And we've mentioned constructors previously for a little bit, so you might be familiar with some of it. But today we're going to dive a little bit deeper into what constructors are and why we use them. So basically, think of a constructor as a special method. And why is it special is only because whenever you create a method, whenever you create your object, this method is going to be automatically called for you. So a constructor, think of it as a way to initialize all of those instance fields, such as variables that your object will have, and other methods that your class has. Constructor will let your object have permission to use all of those. Basically, that's how I look at constructors. So why are constructors different from other normal methods? There's a couple things that differentiate the two. So first of all, your constructor will have the same name as your class with the capital letter. So you know that our names of the classes start with the capital letter. So a constructor is the same way. The constructor's name is going to be identical to your class name. Now, the second thing is that constructors have no return type. So we do not specify a return type when we are creating a constructor, not even void. So you know how we specify the return type in every method that we create? In the constructor, we do not do so. Now, constructor may or may not return any values. Well, technically, it will not return any values, but it will, or it might initialize some values for your object. But technically, it's not going to return anything, any values back to you. Now, constructors are typically public, and then also another thing with constructors is that you can either use the default one that automatically is created for you, or you can specify your own constructor, and we're going to talk about it in a little bit. Now, this is how you would create your own constructor, and you would just put public, and then you would put the name of the class, and then you would open your parentheses and put whatever fields or variables that your object should have. You would put them as parameters. So, and then you would just assign those values to whatever is being passed through as arguments to our constructor. This is the most common way to define constructors in your UML diagram. So you would put, again, your public or private sign, so that stands plus or minus. Then you would put the name, which is a rectangle in this case, and then you would just put the same way you would put whatever arguments, whatever parameters your constructor has, the same way as you did with your other methods. And the only difference is that you are not putting any of the return types, because again, our constructor does not have a return type. Alright, now let's talk about the default constructor. So as I said before, whenever you create your object, your constructor is always called. There is no way your constructor won't be called. So every single time you create an object, the first thing that's being executed is your constructor. And as you probably have seen before, we have not written a single constructor. I have not shown you before this lecture how to write a constructor, and that is because Java makes one for you, the default one. You do not have to write anything. Java will automatically make one for you. And there's a couple things to know about the default one. So first of all of the numeric fields, such as integers, doubles, and stuff like that, those are going to be set to 0. Now, all of the Boolean fields will be set to false, and all of the reference variables are going to be, they're going to have a special value null, which just stands for nothingness. So it just says that your variables are equal to null. Another couple of things to know is that, first of all, your default constructor is only used to initialize your object in a default way. So what that means is that it's just gonna give the default values to your fields, and that's all that your constructor is gonna do. Now, the only time when Java is going to make that default constructor for you is when you are not writing your own constructor. So whenever you will write your own constructor, the default one will automatically cancel and the default one will not exist whenever you are going to be creating your own object. Now, there are arguments and no arguments constructors, and today, right now, we're going to look at the no argument constructor, and we know that arguments are whatever is passed inside of these parentheses. We to have a argument constructor, we need to have parameters in between of our parentheses right here. Now, the default constructor is a no argument constructor, you have to know that, and you can write your own no argument constructor. This is what it will look like. Again, you put your accessor public, then you put the name of your class, then you open and close your parentheses, then you open your curly braces, and then you put whatever values you want your object to have in and initialize them to whatever values you want your variables to have. In this case, length would be 1 and width would be 1 also. Now, what this means is that every single object that you're going to create from the class called rectangle is going to have the default values of length being 1 and width being also 1. Now, you will be able to change them, obviously, with the help of setters and getters, but this is just to show you what your constructor does, is that it's going to assign every single object's length and width upon on creation to 1 and 1. Now, you are allowed to pass your object as arguments, but you have to know that whenever you pass your object as an argument, the thing that's going to be passed is an actual variable that's in the object's memory address. Now, what's going to happen is your parameter value variable that's inside of your method is going to reference the actual object, and then the method that's going to receive that parameter is going to have access to the object. So it's going to work the same way as your methods are working whenever you're passing just your regular data types. All right, now we are going to focus on an important term, which is called overloading methods. And overloading methods, it just means that whenever you have two or more methods in the same class that have the same name. However, if you have the same parameter lists for those methods, then it's going to be an error. An error is going to be thrown. So you got to make sure, if you want to overload your methods, you have to make sure that the parameter list right here, parameter lists, are different. And you can do that with constructors also. And why would we do that? Well, because sometimes we need different ways, several different ways to perform the same operations. And here's a great example whenever we have two of the same methods called add and add. However, one is combining integers and the other one is combining doubles. You can see that parameters are different. These two are integers and these two are doubles. That's why there's not going to be an error, and this is a great example of overloading your methods. So you might be thinking how our computer will differentiate the two, right? In this case, the add, well, it happens with the method signature. And the method signature, it just consists of your method's name, in this case it's add, and the data types of the parameters in the order that they appear. So in this case it's add int and add double. Now, whenever your computer is going to be matching that method call with the right method, that's known as binding. And your compiler uses both the method signature and the binding to find which method is the right one. Hope that makes sense. All right, so now let's look at the little question right here that we have. So if we were to create two rectangle objects, and recall our no argument constructor that we did on this slide. Let me find it real quick. On this slide. So recall that we have this no argument constructor, and then we're trying to create one object with the no argument constructor, and then we're trying to create a second object with the argument constructor. Now let's think what's going to happen, right, whenever we execute these two. And you can pause the video and think about it a little bit and then try to think of actually what's going to happen. I'll give you like a couple of seconds. All right, now for the answer, so the first call is going to create a box with parameters length of 1 and width of 1, because recall our no argument constructor, it would put your length equal 1 and width equal 1 too. However, our second call is going to use the original constructor, and box 2 will be assigned the values that we are passing as parameters. In this case is 5 and 10. So length is going to be equal 5 and width is going to be equal 10. So these two, you can see that we are just using different constructors. However, we are going to have completely different values assigned to each object, even though seemingly we're using the same constructor, but in reality it's not like that. Now let me show you a couple of examples of overloaded constructors and how they would look like in your UML diagram. In this case, this one is the bank account. See the matching name? This is how you know this is a constructor, because they match with the name of the class, bank account, bank account. Now this one is no argument constructor because there's no parameters here. Now this one is an argument constructor that has a start balance double, that you can assign a special value of start balance whenever you're creating your object using this constructor right here. Now these are all for context, so this one is without arguments. This one you can assign a name whenever you created your object, and this one will let you assign a name and email whenever you're creating your object. So as you can see, we have 3 different constructors here. However, they all will let you do a different thing to your object whenever you're creating your object. Now a little conversation about the scope of instance fields, and you know that instance fields are just variables that we are creating inside of our class that are going to be assigned to each object, and well, instance fields are going to be accessed by any of the instance methods in that same class. However, that is if you make them private. If you make them public, anything, even the code outside of that class, will be able to access our instance fields, and we do not want that. I explained that many different times why that's not a good coding practice. If you don't remember, just watch a couple videos back and you will be able to recall it. However, another term that we need to know is shadowing, and shadowing, it's just whenever shadowing happens whenever we have the same name for a parameter as an instance field, and that is bad coding practice. We do not want that to happen. We don't want to do that. So whenever your methods, let me show an example right here real quick. In this case right here, right, we have a method local variable len and methods local variable w, and then we have length and width that are our actual instance fields. So if these with this len was called length and w would be called width, that would be shadowing, and that is a bad coding practice, and we do not want that to happen. So instead of these, if it was length, and instead of w it would be width. So you would see that these two are identical to these two, even though these are our instance fields and these are just our parameters. So that is why we do not want these to have the same names. That is why we change them, to avoid shadowing. Now let's talk about packages, a couple of more slides and we will be done. Just bear with me. So packages and import statements. You may remember that whenever we were working with files and scanners, we had to import some of the packages, and that is just because we do not want our Java program to be a gigantic size, right? Imagine like you're downloading your Java and it's a couple of gigabytes of memory. Nobody would want that. So that's why whenever you actually need your import statements, that is when you're going to use them. So you will specify that you want to use this specific class, and in this case, import java.util.scanner, we would import scanner. And you can also do a wildcard import. That just means that you're going to import the whole package, and in this case is import java.util.star. So whenever you put star, everything that belongs to the util package is going to be imported into your program. Now these are the standard packages, a couple of them that you need to know, and you can pause this and read this table. And the last slide that we have is our object-oriented design slide. And these are just a couple of things that you need to know whenever you're working with object-oriented design. And so first of all, you have to be able to find the classes. And what that means is just you have to identify everything that can be a potential class. Then write description of your problem domain, so what you need to fix. Then also you need to refine that list of the potential classes and only include the classes that are going to be relevant to the problem. Then you have to identify all of the responsibilities. So you have to figure out what your class should have, what your class should be doing, and then again refine that list to include only the classes that are relevant to the program. So we're going to be talking about this later on, but this is just so you're familiar with object-oriented design. And that is it for today for chapter 6. Let me know if there are any questions, and I will see you in the chapter 7 video.